So I've started to design this camera. I've been daydreaming. So if we're looking at this design, comparing to the newest camera that I made, or designed rather, yeah, this has a lot of footprint. I mean, I wanted this specifically, but the new display is touchscreen and it's bigger. It's bigger than this one. You can't really see that. But the other thing is, the orange camera I built with the round display, you use one of these 5D joysticks. So you go left, right, up, down, center, click. So that's what's going to be right here. And then there will be a dedicated back button. But that whole thing is touchscreen, so you really shouldn't use that, or don't have to use it, but it'll be there. And then since this display is not, it's not a SPI display, SPI, it's using HDMI, or not HDMI, it's using the Raspberry Pi's display out cable. It looks like the camera cable, the flat ribbon. So the OLED thing, I don't know what the purpose of it is for, but I wanted to add one because they're cheap. You just get them, and they're pretty easy to use. So it's you could have something on the top. I'll probably end up centering it, or I don't know. It's purely artistic versus functional. It's this color, sea green. It's nasty, but I'm thinking of, I knew somebody that had this Ryobi tool. Actually, I'm not even sure it was a Ryobi, but it had mixture paint on it. It was it was a cool artistic look. I'll actually find it and pull it up, but this was the nail gun. It had a bunch of coats on it. It's a red on one side, and it's green and yellow, and there's a bunch of chips on it. That's pretty cool. That's my own hand. But I got this urge to build the camera, and I bought the Nikon and Canon versions of these, so I'm gonna go buy some other lenses and I'll tune them. But yeah, so the other thing I was thinking about is these lenses have this little thing that the flange, so I have to look at the other ones and see how much they differ, because I've been thinking about having the pie sunk into the body and you twist the lenses into them, so then these guys are kind of flush with the body. It doesn't stick out like that. So that's something I'll look into. But that also means the body will be thicker, so I don't know. The pie will be in there. It's a full-size pie too, not a Pi Zero. So it's and I definitely want to put a accelerometer in there just because, I was thinking something like this where you can resus the adapter. Although that means you couldn't use the regular C-mount lenses. You could if they're the same width as this part. I don't know. I just don't like how there's this little tiny neck, I'm also not designing this to be modular. It's just going to be as is. Specifically the HQ cam. You can't swap modules. So I've shown this before. This is the 2.8-inch wave share display. It's touchscreen, so the thing that's different about it with the other cameras, aside from being touchscreen, is it's using, I think it's called DSI, but it's the cable that goes into the Pi. This one, display. I've not used that before, so I gotta figure out how to use that, because I don't want to use the heavy operating system where it has the GUI. I try to use the light, and I don't know how to display. I imagine it'll display that terminal, so I'm gonna have to figure out how to control what's being displayed through this cable in order for me to show the menu and the camera output and all that. I also have to figure out how to power this thing, which it's crazy. The PCB is fiberglass, or you see these fibers. I see 3 dots here. Let's have clock data. There's no ports, so yeah, somewhere around here I can power this thing, unless it's powered through the display. I don't know if that's a thing. I need to find a cable. Oh, check this out. Maybe it's powered by that display after all. It's blinking green. What does that mean? Is this an SD card? Yeah. Because literally, I don't know where you would plug power into this thing. These 3 things here look interesting, but that might be like a programming port or something. It doesn't have labels. Or no ports on the edges. I gotta see, maybe I'm missing like some kind of software. I also gotta see, maybe I have to wait. Damn, I hope they dumb-proof this thing. So the cable is different. Like, this is a camera serial interface, and the DSI cable is something else. So I gotta find the box and see if they sent me some of those cables. Pretty sure they did. I remember I had a bunch of them. So what's interesting is they send you these 2 DSI cables. This long one, which I wanted to use, it goes to 22 pins. I guess it's like for a Pi 0, but I don't know why this one is so short. I'm gonna have to find a longer one if I want to design the lens to open. I was even considering making it flip out this way, but I don't think it's gonna be possible with one of these kind of cables. You have to choose, like, flip it front or flip it up. I think for me, it's not really like a vlog camera, it's a photography camera, like, so I would have it just flip upwards. But right now it's still not displaying, so I think I'm probably missing some kind of software. Okay, so I guess the Pi 5 is what uses this 22 pin display, not the Pi 4. So that's why they included one of these cables in there. But I think I'm still missing like a flag in the software to figure out how to use this display, so I'm gonna look into that. Okay, here it is. This is legit. Yeah! Had to add a DT overlay. This man is hacking. It looks good. It's crisp. Like, I could read those letters with my eyes. Is that amazing? Wait. Wow. Wow. Oh, I can't change the aperture once I'm filming. Dude, that is legit. Look at it. Damn. That's game changer, baby. So yeah, so from here, I have to get the, well, there's 2 things I gotta do. How to control this display out so I can make that dynamic menu based on the pill layer compression thing, PIL, like pillow library. The other thing is the touching. I need to get the coordinate wherever I touch and then translate that to the menu. That's cool, man. It looks good. This display is $50, so I was like, you know, yeah, it ain't no spy. Okay, so making progress. That's so crazy. I had no idea this thing works, and now I've gotten pretty far. So what you're looking at right now is the login screen, you know, if you plugged it into a monitor, type in your username, password, whatever. So, what you have to do, you're using stuff like X11 server, Openbox. You have to produce a window, and I guess the window could just be an image, and you show that. What I have to do is create like a video stream from the menu images, and also when you do live pass through the camera footage. But I also want to point out this thing's resolution is nuts. Like 640 by 480 doesn't sound a lot, but when you open that on a computer, like that's big. So it's like that's why you can read this tiny text. I tried to turn the contrast down a lot to see it. But yeah, so I just found like a demo, you know, how do I open a window and show it kind of thing. 1 second. That's here. You see a little cursor. And I had to figure out how to turn this around. And then yeah, you can see there's like a, so the direction matches, because I had to figure that out too, how to flip the touch. But yeah, so I'm working on the menu thing right now. Then once that's built, then I'll work on Pelican, which will manage the state of the camera. So it's like there's an order of things, like you run Pelican first, and then you call this thing to, well, you use this thing to execute Pelican, and then Pelican would produce the menu. But yeah, this is just completely different than what I had set up for these spy-based cameras where they're just showing an image. But you know, this thing has like 60 frames per second, so it's going to be smooth, provided the code is good. But yeah, still working on that. Oh man, well, there it is. I don't know how freaking difficult it was just to get this blank page. But now, this is, you know, you can turn this into a loop and it's a stream, and then it just shows whatever you want. So, I'll have to work on that part. But yeah, I'm gonna hide the cursor because I see that right now. It's crazy. I was thinking about, like, you can make themes for the menus, like Windows Phone, you know, the tiles, Windows Metro. I also want like cyberpunk, just, you know, crazy looking menu. But you can do that because the menu system will be easy. You just replace the icons, and, you know, it's like a nesting thing. But yeah, I still have to make that. Don't let your dreams be memes. Look at that. There it is. Seafoam green, baby. I'm still not ready to print, but yeah, I got it. Our new camera's gonna be freaking seafoam green. I also got these. I'm not gonna be able to open that, but it's the OLED, so it'll be a 1-inch OLED strip. I still don't know what it does, but it'll be there. Maybe you can show the camera settings or something. Okay, so at this point I've got the click event. Let me start this up real quick. So there's Openbox, X11 server opens the OpenCV GUI window. Then I removed all the, you know, menu options or whatever. And then the cursor is hidden, but when you click, it shows up. But what I'm trying to say is the clicks are detected right now. So if I, so it's 00 up here. It's 640 across and 480 down or something like that. So I'll click up here. Oops, I'll click up there, click over there, click over there, click over there. Then I'll look at my logs. Okay. And here you can see that it's logged the coordinates. So top left, then I went to the right near the top. I went back to the left but near the bottom, then back to the right bottom. I double clicked. But yeah, so that's the basics of the menu. Like, you know where you're clicking, and then it's just a state-based image generator, and each icon has like a function it's bound to. But I'll go into the software stuff later. But yeah, I just had to get this running because this is literally a login screen. It's not like Spy where you say show this image. So that was new for me. Got the 0.91 inch OLED right here. Look at how freaking tiny that is. It looks to be a very basic like serial. It has 4 pins. Oh, it's so cute. Look at it. I wish it like stuck out more, like upwards, so then you could put it flush in the design or whatever. I'll have to see how that goes. It's really neat. Look at how tiny it is. So I've got that. Got our shutter button right here, which is just basic. Came with these O-rings. You put them underneath. Very thick wire. That's nice. I've already interfaced with the touchscreen display. Got this 5D D-pad thing right here. Let's go up, up, down, left to right, and center click, which I have to make sure that works. If you look at the pinout, it tells you what each pin is. It's really simple. It's just connecting or closing that circuit, whatever thing you click. So the pi, you'll put a resistor in between there, but the pi will just have a high means on, and it's just polling at some speed. And when it goes high, then that means that button was clicked. So that's really basic. Here we've got this is I think they call it a 10-axis IMU, but it's got your standard accelerometer, magnetometer, and gyroscope. But I don't know what the other one is. This is GY91. I think it's like temperature or something. There's something extra that it does. Yeah, we'll get this in there. So we've got like a horizon level thing and orientation detection. It's just, you know, bells and whistles. End of the day, it's supposed to take pictures, but why not make it cool? Oh, and here are the hinges, which we're gonna have this display. It's gonna flip up. If you're looking at it side on like that, it'll flip upwards. I thought about making it flip, you know, like forward and then be able to go up. It's possible. You just need like a really long cable. But at the same time, this isn't meant for like vlog, you know, so I don't think I'll make it flip. Well, the other thing too is like, even if you had it flip forward, and all it did was tilt up, it's not really useful. Like if you had it tilt down, and it usually rotates around the center. So yeah, and I'll just go with the tilts upwards. That way, if you want to take photos, you know, and have it like waist level, you can tilt it up and look at it. So yeah, I'm gonna go ahead and write some small snippets of code to. What I'm trying to do is get all the GPIO pins, and then I can do the wiring diagram. And then from there, you just model all the parts in 3D and then draw the shell around it. And then you can do some test prints like thickness and then screw the hinge into it and then see that it's strong enough. Do some test prints to print other things before you commit to printing the entire camera, because the entire camera, like each half will take, I don't know, maybe 10 hours. So it's like, you gotta get it right. Oh, I did forget to mention, this is what I'll be using to power this camera. It's a protected 18650 cell. And then you use, let's see if I can find one. called a boost converter. Anyway, you also need one of these, which is a BMS. This might be a 2-cell one, but I have a 1-cell BMS somewhere. So you also put that around the battery so it's protected. And you have a switch. And then the other thing you need is a charging board. Oh yeah, the DC-DC boost converter looks like this. So that puts it up to 2 amps, which I think is enough to run all this. I've got some more expensive ones that go up to 3 amps, but it's probably good. So yeah, I just gotta go through and wire all this stuff up, and then I'll have a wiring diagram. Alright, so I got the interface working for this. Oh man, I'm like wondering if I should have bought blue instead of white. I mean, it's so cheap, why not just buy them both, you know? Yeah, so here it is. I'm just using their example code from Waveshare. Ooh. Let's get a close-up of that. I'll have to rerun it. That's pretty cool. Okay, so I'm moving on to the accelerometer now. I think I remember what the other thing is. I think it's a barometer. But yeah, for sure it's this microphone looking thing here with the little tiny hole there. But yeah, I had this in the first camera I made, the Pi Zero HQ cam, so I should be able to just use that. Was it that one, or it might be the modular Pi cam that has it? But anyway, they've got these in there. I think it was only the HQ cams. That's the one where the telemetry actually worked. But yeah, this tells you like the direction of gravity. If you turn it like this or this, also like rotation, bunch of stuff. On cameras, that's how you get like the angle of the horizon. But I never actually implemented that in my cameras though. But the sensor will be there, so you can. My bad for filming a camera screen, but I was looking at the wiring diagram here, and it specifically calls out 6050. So I guess it is this one that has it. I must have like turned it off in the startup, but the one thing I wanted to point out is for this new camera, I'm gonna avoid these sharp edges because this camera has sharp edges. Like those are rounded, but like this right here is sharp. I was trying to make it more ergonomic. Okay, so I've got this plugged in. I'm using the second I2C bus 0 for it. The first one, number 1, is for the OLED. You can use the same buses, but I just didn't want to deal with the whole, you know, multiple wiring resistors, blah blah blah. I had to do that for the, you know, the quad lidar, tri-lidar mouse thing. It was a dumb project, but yeah, so I just took the code from Pi Zero HQ Cam for this because it already works. So got it here. Let me focus on there. And then I hit run, and there's the values, which it's XYZ, and you can see it's upright. Z is almost 1. That's the value of gravity. It is a little turned. Like here it's, I don't know, maybe perfectly flat there. See the value? It's like 1 or 0.9. If I turn it parallel to gravity like that, then that value goes to 0. And another axis is 1, so like Y is 1 now. That's how you can tell orientation just with the accelerometer. So we got that wired in. I started drawing the MS Paint wiring diagram just to remember how to assemble this. That's the thing, once you interface with it, like you've got code that can talk to the sensor and pull the values, then it's just a matter of like soldering it on a permanent thing, which I've got these like PCB boards that are just, oh god, blank generic boards that you can solder to. And then yeah, you got to design the body and, you know, test all the parts fit in there and whatnot. But yeah. So next I'll just do the buttons over there. That one and the there's also going to be a back button, which I got a bunch of them here. It's just gonna be one of these. That's like a dedicated back button right above the 5-dimensional pad joystick thing. 5-direction, not 5-dimension. But yeah, so making progress there. That one is pretty straightforward. You just wait for the, you know, the connection of the circuit, which I'll just throw that on a breadboard to show that it's working. So here's the wiring diagram for the Pi Zero HQ cam. For the buttons, you see all the connections just go to a single resistor. This I need to have, this steps down the 5 volts to 33 volts. You could just use the Pi's own 3.3 volt out for that. I mean, I might do that because it's, you know, because this is just like a waste of power stepping that down. I'll check if you need to have like a current thing on there, resistor, but yeah, I might just do that. Yeah, so here's that BMS I was talking about. It's so cute, so tiny. You put this around the battery, and then when the battery is like too low in voltage, it stops allowing you to pull more from the battery. That way it doesn't die, damage the battery. I just gotta find the charging module now, this USB thing. And then I'll lay out all these parts on a piece of paper so I can take a picture of it. Alright, here's the charging board right here. I think it's like 1 amp. Then we've got a boost converter here, which this is sitting in my drawer for some reason. I don't know if it's just like extra. I'm gonna test right now if it works. So it has 4 volts right there. It should put out 5 volts here when I touch the DMM to it. This is tough to do with one hand. Let me see if I can do it. Oh, it's not on. Output. Shit, I got them backwards. Ooh. Nice. I see it's putting out 5.11 volts. 5.1 volts. As long as it's a little bit above 5, that's good. So that's what will feed the Raspberry Pi and all the sensors. Everything is 5 volt based. Except the GPIO, that's 3.3 volts, so the Pi will feed itself with the buttons. One thing I want to point out is on a Raspberry Pi, the GPIO pins, some of them have specific purposes. I mean, in general, you can remap them, aside from like the ground pins. You know, like this black one right here is a ground pin. But yeah, so it's like there's an I2C bus up here, I2C bus here. There's UART. There's like SPI over here. But for the buttons, you just find some GPIOs and you tell the GPIO what to do. In that case, it would be an input, like it's waiting for a spike, whether it's on or off. On being 3.3 volts and an off is like 0. So that's all I'm doing for the buttons, which there's 7 of them. The 5D joystick has 5, and there's one for the shutter and one for the back button. The display is completely standalone. It's the DSI cable, so that's nice. That saves a lot of pins. So There's a 10k ohm resistor, 0.4 watt. There. It's funny. I got some help on like a circuits, all about circuits thread. This guy put together this list. It was like $100 worth of random parts to make like a solar charging circuit or whatever. Some of the parts that came were so small, like you could barely see them with your eyes. And I was like, damn. It's meant to be assembled by like a pick and place or something. But yeah, that was like crazy. It was a waste of money in a way because I didn't end up using it at all. Just like outside of my skill range at the time. But oh well. It's nice that people will help you like that. So yeah, right now I'm setting up the button testing. So here's the 3.3 volts. I like to use like orange, showing it's like less. And I'll take this resistor I have here and put it in between the button I'm testing before it goes to ground. And then, or it's not going to ground, it's going to go from here. Actually, do I even need ground? I don't think so. It's just going to go back into the Pi. And the circuit will be completed when you click the button. So I'm going to set that up and write a loop that'll check for it. Which I already have that code. It's a class I wrote, yeah. Alright, so this is the last thing I'm interfacing with because the rest of it is repetitive. You can see here the 3.3 volt wire goes into the breadboard. There's a resistor between them, between these two wires, the 10k ohm. And this wire goes into COM on the 5D joystick. COM can be power or negative, just depends what your setup is, but I go on as high. So, and then this is the up. So when you push up, it connects this circuit, and then the purple goes back into the Raspberry Pi pin, which I've set in the code. It's waiting for that value to read if it's high or low. You can see in the code here, the loop. A lot of it's commented out. I just wanted to test one, but see here it says like if it's high, you print up. So now when you run the program or script rather, oops, that's clear. Here the loop is running, Python main, and if I click on here, like in the up direction, see the U, it will show that. It's hard to get these. Okay, there we go. Up, 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 up. So yeah, the one thing I want to check is the center. So I can just unplug that and test real quick. Okay, so I've got the center one switched. It says middle. If I click this, it should increment this. Oh, there we go. Yeah, so it's just a matter of the sampling rate is slow. But yeah, it definitely works. So let me push it down. No, it's not working. It's probably just loose. Yeah, there. The wires are just loose. Yep, so the middle button works. I bought only one of these last time and for the orange camera, and the center click didn't work, so I didn't have a center click. That sucked. So yeah, everything is there. I'm gonna take a picture of all the parts so that, you know, other people could reproduce this project if they wanted to. But yeah, the next part will be there's two parts. I think I said that before, but I gotta model all these parts, which I've modeled some of them already. I gotta design the shell, do some test printing for fittings and strength of plastic kind of thing for screws. And then the other big thing I have to do is build the menu system, which I have a new menu. It's based on like how certain web servers, their routing is set up. It's like you have a file, and then if there's folders, those are like sub routes or like files that are next to each other. They're like other route endpoints. But yeah, that'll be another video where I talk about that software, because the previous code I wrote was just nasty. It's like manually checking state. Check and show it in here. The menu. You can see the menu map here, like how many states pages there are. But in the code though, it's like checking the state through a bunch of if statements. And it's like, if you go this direction, it's that. Which is really bad. I want a nesting file structure thing to specify how the menu works.